Hello. Today we're going to be talking about writing chemical names and chemical formulas in the form of a review. If you are new to this content, you may want to search out other videos because there may not be enough information to help you out. The materials you need for this video are a periodic table. When we take a look at ionic and covalent compounds that are commonly mixed together, the most important thing to take a look at is going to be the first element. NaCl and N2O5 both look very much the same, but they're named by different rules because one is ionic and one is covalent. When I look at my first element, what am I looking for? Well, I'm looking to see where it falls on the periodic table. The periodic table is divided by a stair-step line, and that stair-step line divides my metals, which are to the left, and my nonmetals, which are to the right. And if my first element is a metal, and here's sodium, and sodium is a metal, I'm going to use ionic rules. And if my first element is a nonmetal, and nitrogen is a nonmetal, nitrogen is found right about here, then I'm going to use covalent rules. So when I take a look at my first element, if my first element is a metal or NH4, NH4 is a positive polyatomic, and it's made up of nitrogen and hydrogen, which is two nonmetals, but they have a positive charge and they fall into the ionic category. If I'm naming an ionic compound, I need to pay attention to my charges and I need to pay attention to my endings. And we'll talk more about that below. If I have a nonmetal, that means it is either going to be a covalent or molecular. Both words are used interchangeably and they follow the same set of rules because they're the same compounds. If I'm naming covalent compounds, then I need to be familiar with common prefixes. And again, we'll take a look at that. So when I'm looking at my periodic table, there are two things I'm going to be paying attention to. The first is that stair-step line that divides out my metals and my nonmetals because that separates out ionic and covalent. If it is an ionic compound, we talk about charges. And on the periodic table that we use, I've got charges already written out on the periodic table. So here's a charge of +1 that works for the entire first column. Here's the +2 for the second column, and so on. If you take a look at your transition metals, their options for charges are going to be found inside their actual boxes. So let's take a look at a couple of examples and see how we actually do this. So when I am writing names for chemical formulas, my first thing is to look at my first element and find that element on my periodic table. So Fe is iron, and it's found here on my periodic table. And I'm looking for more than just its name. I have to pay attention to its charge. Now, when I look at iron on my periodic table, and this is a little bit enlarged over here, I see that iron has two or more charges. With an ionic compound, any compound that has two or more charges needs to have parentheses in a Roman numeral. So when I write the name iron, and I can just write iron just the way it is, I have to include parentheses, and I have to put either a Roman numeral 2 or a Roman numeral 3 in there to be able to tell me which charge it actually is. Now, my ionic compounds can be paired with a single nonmetal or two or more nonmetals that are paired together. If I have two or more nonmetals paired together, it's called a polyatomic, and this is carbon and nitrogen together. And I can go to a list of common polyatomic ions and look up the name on there. So this is going to be CN, and CN here says that it's going to be cyanide. And if it's cyanide, I'm just going to write the name. So this is going to be iron something cyanide. Now, the other thing I need from cyanide is what's beside the ion. And cyanide is going to be a 1- charge. With an ionic compound, we take the charge from the positive and switch it with the charge from the negative. So ones are not generally written, and when I have nothing written here, that means 1. That came from the cyanide. With polyatomics, polyatomics are put into parentheses And the subscript from the metal is going to go from the on the outside. So here's a 3, and that 3 must mean it comes from iron. So this is going to be iron 3 cyanide. Going on to the next one, I find my first element. It is K. K is potassium. I find potassium on my periodic table, and potassium is here. Unlike iron, it does not have charges in the box because I'm going to find potassium's charge above it. So potassium is going to be a +1 for a charge. If potassium is a +1 for the charge, I don't need to worry about it. I can just write potassium. If its charge is always the same, oops, spelling error here. If the charge is always the same, then I don't have to worry about it. So no parentheses, no Roman numeral. Potassium is also paired with 2 or more nonmetals. CO3 is carbonate. And so I'm going to go up to my list, and yep, I know that it's carbonate, but I can go and check here and find that it is carbonate. And I'm going to write down carbonate. So my next nonmetal, it's different because this is nitrogen. And nitrogen is found on my periodic table, but I am to the right of the stair-step line, and that means this is a covalent compound. So if it starts with nitrogen and it's not NH4, I have to use prefixes. There are common prefixes for covalent compounds. The rules for writing this are to put a prefix on the first nonmetal, and in this case, my prefix would be di, which is 2, for every number except for 1. If I have one nonmetal, then I don't write that prefix. So this is going to be di-nitrogen. No, I do not switch like I do with ionic. Ionic charges switch, but with a covalent compound, it just says exactly what it is. This says 2 nitrogen because I have 2 nitrogen. With my second nonmetal, I am always going to use a prefix, and the prefix for 1 is going to be mono. But then I also need to change its ending to "ide." So this is dinitrogen. This is going to be mono. With oxygen, I do not put 2 O's in a row, so I drop one of those, and this is going to be monoxide. Very similar to carbon monoxide. So I'm going to take a look at my first element, and my first element is going to be cobalt. I find cobalt on my periodic table, and cobalt is here. Like iron, cobalt has a 2 or a 3 charge, and that means I need to have parentheses to go along with that. So because I know that this could be a 2 or this could be a 3, I'm going to write cobalt. I'm going to put parentheses, and since it's a 2 or it's a 3, I'm going to wait. This is paired with a single nonmetal. Single nonmetals I'm going to name with an "ide" ending, so this is going to be fluoride. Now fluorine is a 1- charge. That's why I do not have a subscript here. The 3 comes from fluorine, or from cobalt, so this is going to be cobalt 3 fluoride. So I want you to pause the video. I want you to try 5 through 10 on your own, and then come back and check the answers. So how did you do? Pause the video again and check your answers. Make sure you're careful checking to see that they are actually correct, especially with the endings. Please note on number 6, there is no mono prefix on the first nonmetal. Very similar to carbon monoxide and carbon dioxide, we don't say monocarbon. This is carbon tetrafluoride. The second is check number 10, because that's tricky. Lead can be either a 2 or a 4. And while there's a 2 here, you've got to make sure you're checking selenium's charge, which is also a 2, because they simplify each other out in order to make the formula PbSe2. If they were both 2's, you would just have a formula that would be PbSe. Now, let's take a look at writing chemical formulas. So we use the same rules. We're still going to look at charges and endings for ionic, and we are still going to take a look at that first element to make sure that what we're taking a look at. So this one is carbon, and carbon is a non-metal. There's also a hint because if I see a prefix, I should know that prefixes are covalent. Now, covalent prefixes tell you exactly what the formula is. Tricarbon, the prefix tri means 3, literally means 3 carbon. And I have 3 carbon that I'm going to write C3. Octafluoride literally says 8 fluorine. So I'm going to have F and 8, and I'm going to have a formula C3F8. Sodium, however, is a metal. And I've got to work a little harder to get the formula for sodium because sodium, I have to pay attention to charges, and I also have to pay attention to endings. So that I'm going to go to my periodic table and find sodium. And sodium's right above the potassium that we were looking at earlier. Sodium has a 1 plus charge that I need to use. But the other thing I need to take a look at is my polyatomics, because I have phosphate to find phosphate's formula. Phosphate is going to be PO4 with a 3 minus charge. So when I'm writing a chemical formula between the two of them, I have sodium, which is Na. Sodium's charge is a 1. I have phosphate, which is PO4. It has a charge. It is going to be a 3. And with ionic compounds, I am going to switch those charges. So phosphate's 3 is going to go to sodium. And since sodium has a 1, I don't need to do anything else. So I have copper, and copper is going to be a metal. So when I go up to my periodic table to find copper, and copper's here, it can have a 1 or a 2 charge. So copper will give me a Roman numeral to tell me what its charge actually is. So that I have copper, and copper is going to be Cu, and this charge is to tell me that it is a 2 plus. I have to make sure I'm paying very close attention to my endings. Most ide endings are just single nonmetals. Sulfur turns to sulfide, so this is just sulfur. But my nonmetal has a charge as well. So when I go to my periodic table and I find sulfur, I need to look above sulfur to find sulfur is going to be a -2. If sulfur is a 2 and copper is a 2, they will simplify each other out and cancel out the charges. So I can just leave it as CUS. They both become 1s, and 1s are not written. So I have lithium, and lithium is a metal. Lithium is a group 1 metal, like sodium, and it is going to have a 1 plus charge. This is paired with chlorite. Chloride is a polyatomic. It is going to be ClO2. And with a polyatomic, I always have to look above to find the superscript. That 2 is part of chlorite. I'm going to look for the superscript that's going to be up here. And with chlorite, you're either going to see just a negative, which means that it's a 1 negative, or sometimes they'll give you the 1. All right, so if chlorite is a 1 and lithium is a 1, they cancel each other out, and I don't need to write anything else. So I need you to pause the video. I need you to try 15 through 20 and then come back. So pause the video again and check your answers. Please note there's a couple of messages off to the side. Polyatomics that I write a subscript on have to go in parentheses, and you have to be careful with ammonium. The best way to figure out chemical formulas and names is to practice, and there's plenty of resources online to help you with that.